norėtume pradėti šios dienos seminarą. Smagu matyti jūs dalyvaujant mūsų seminare. Ir apie kągi mes šiandien kalbėsim. Tai turbūt ne vienas iš mūsų susidurėt gyvenime su tokiom problemom, kaip kad mūsų aplikacijos staiga pradeda, sistemos, kurias naudojam, staiga pradeda dirbti labai lėtai arba iš vis nustoja dirbti ir labai sunku yra nustatyti, kurgi yra problema. Ar tai yra problema dėl to, kad yra kažkoks tai įrangos gedimas, ar tai yra kažkokios tai kitos priežastys. Ir dažniausiai tam, kad nustatyti tą problemą, iš tikrųjų sugaištam labai daug laiko, nes nagrinėjant atskiras komponentės akivaizdžios problemos nesimato. Nes įranga lyg tai veikia gerai, serveriai neapkrauti, diskų masyvai veikia gerai ir matyti tokį pilną vaizdą iš tikrųjų labai sudėtinga. Ir todėl šiandien norėtumėm pristatyti IBM produktus Instana ir Turbonomic, kurie yra skirti būtent tokiai analizai ir akivaizdžiai parodyti, iš kokios sistemos yra tarpusavy susijusios, kokios yra tos sąsajos ir kur tarptų sąsajų yra kažkokios tai problemos, kurios leistų mums išsiaiškinti greitai, kur yra ta problema. Kitas dalykas, kur gal dažnai mums irgi yra pakankamai svarbus, tai yra efektyvus išnaudojimas turimų resursų. Nes kartais būna taip, kad tam tikrais laikotarpiais sistemos reikalauja daug resursų, kaip procesorinių, atminties, bet yra tam tikros atkarpos laike, kada tie poreikiai yra mažesni ir mes dinamiškai perkeliant tos resursus prie kitų sistemų galėtum turėti žymiai geresnį rezultatą. Tai kviečiu dabar išklausyti Maciejaus prezentaciją apie IBM Instana ir Turbonomic produktus, o savo nuomonę norėčiau, kad jūs pareikštumėt, ar šie produktai yra įdomus jums ir galbūt norėtumėt kažkokiu tai konkretesnių diskusijų dėl šitų produktų panaudojimų pas jūs IT, reiškia aplinkoj, pažymėti apklausoj, kurią Elena pateiks jums seminarui pasibaigus. Tai tiek pradžiai ir kviečiu Macijų pradėti prezentaciją. So, Macijai, welcome on stage.
Hello. Unfortunately, I don't know what Miroslav has said because unfortunately I cannot speak, Lithuanian. All I can say is Laba diena, that's all. So Laba diena. And now maybe I will start with saying something about me, who am I and why I'm here. So I'm a technical person responsible for all the product related to IT management in Poland and C in general. So I'm not responsible only for Poland, but also for wider set of countries. And that's why I'm here today, showing you, some good information about two products, IBM Instana and IBM Turbonomic. So let me share my screen because it is usual the best thing to do at the beginning. So let me share it, which is not so easy. I'm not used to use this platform we have here, but possibly I will do that. Let's stop sharing. Why I'm sharing? Yeah. Share screen, yes, and now pick the proper one, which will be my presentation, which is here. Yes, I would assume that you can both hear me and see my presentation. Is it true? Miroslav, can you tell me?
Yes, Yes.
Wonderful. Yes. So thank you for that. So let's not waste the time. Today we'll be talking about, let's say, IT management products in general, two kind of those. But the first will be, I would assume, quite known by most of the participants. I mean, the technology, the area that I will be covering, it is APM, Application Process Management. The second one, which is ARMs, which stands for Application Resource Management, is not as known as APM. However, I will also, tell you what is the reason we have ARM products on the market. But before that, I would like to tell you why we are covering those areas. If you're working for IT for, let's say, a few years, then I'm pretty sure you are familiar with all the APM products. I would assume that each and every company out there has already, which is responsible for monitoring of your application. And still, even you are using those products that you have. Still, I'm saying that there is something new which we need to cover, which we need to have in order to monitor our applications. Why is that? Why we have something new? The first, problem, the first thing is the complexity. If someone would ask me, what is the best word which describes IT these days? For sure, it's a complexity. Our applications are quite complex. They are, changing, beginning to be even more complicated than before. Everything has started with our infrastructure. Yes. Let's say in the old future, we used to have physical servers. That was quite easy to manage, of course. It was just one box. We need to check if it is working or not. Maybe it has some kind of problems, maybe not. It was quite easy. One box per application, more or less. Then we have managed to divide those servers into smaller ones, the virtual machines, which is more complex to monitor because we no longer have one box to monitor. In fact, we have 10, 20, 30, 50 boxes per each of the servers. So it's more complex than we had before, but it is not the end. Today, we are rather talking about the containers, not only the virtual machines. If you are talking about the containers, then we have a lot of those running on those virtual machines. And it is not the end. We've got also systems like Kubernetes or cloud systems, which gives even higher level of complexity than we had before. So our monitoring products, our IT management products needs to be created for those new ways we are developing our applications. But the infrastructure is not the only part, the only thing that has changed. We've got our applications. You may think that, applications are still the same. Yeah, we are creating them like we used to do it before, but it is not true. Application has changed as well. We have started with the concept of monolithic applications. The monolithic application is more or less a single piece of code which is being developed by a group of developers who are responsible for delivering whole functionality of that monolith applications. And this is the way we're creating applications for many years. Even today we are still creating those huge complex applications embedded into one application server. That infrastructure was quite easy to monitor because exactly as we had with our servers, there is only one box, one application server we need to look at. So quite easy. Then we have migrated to the concept of service-oriented architecture, our SOA, great concept. The idea behind that was that if we will get a huge portions of the functionality from the monolithic application and develop this externally, like, another application, it will be easier to reuse those components and we'll be able to do our programming faster than we did it before when we are creating the monolithic application. So we have divided those applications, connected them via, SOA service bus, like our IBM products or even, competitive products. And it was harder to monitor because we no longer had one box to monitor. We had multiple boxes connected together. So we had to look on those, messages going via the service bus. So it was harder. But today, we are no longer telling about the SOA concept, SOA applications. We are talking about the microservice application, which are completely different kind of beasts. The idea is crazy. The idea is that let's get even this small portion of code from those monolithic applications and develop those externally. So we no longer have one application. We have something like 30, 50, 60 applications that are being developed by different teams of developers. So it is completely different way of working. Those components are connected together via network. They are dependent on each other, and they are exchanging the messages, the calls via our network infrastructure. So we have to monitor not only those components, those microservices, we have also to monitor, to track the transactions, the messages that are going between those components. We also have to get to know the relationship between them, how they are connected together, how they are forming our application. So it is completely different way we are looking on those applications. But the infrastructure, the application, it's still not the end. We have something more. The more is the way we are creating our projects. Probably, some of you are working in so-called agile environments. So you are doing your runs, you have your scrums and all the other, ways of working with the projects. But for us, for the persons who are responsible for keeping the application running, the new ways of working the application means only one thing. The thing is that the applications are developed faster. Of course, the changes between each release are smaller than we used to have for the monolithic applications without the agile methodology, but those new versions of applications are occurring, let's say, bi-weekly, 3-weekly, monthly. Yeah, that's the time span. So we have to be prepared for constant changes. Then we have to prepare for DevOps culture. From the developer standpoint, the operation team is no longer a dragon. Yeah, they call it the operation teams are the dragons. We are the good guys. The operation teams are the dragons. It's no longer true. These days, where we are utilizing the DevOps or even DevSecOps methodologies, those are friends. We are working together to keep our application working. So we need to have tools which will be good for both recipients, for the developers and for the operations teams. And then we need to work faster. Our reality is that customers don't want to wait. If they have to wait for a new functionality for, let's say, large amount of time, they are utilizing a competitive products. Yes, as you could see for the social platforms like Zoom, WebEx, or that kind of platforms, when we had a COVID, problems, the platform which was the first, the fastest was the best. That's what the reality. So we need to work very, very fast, and yeah, we don't have much, money more. So we have to work smarter because we have to deliver more. We have to keep those smaller applications running. We need to be prepared for those constant changes, and we will not have more money for our teams. So we have to have a good tools. Of course, you may think that, yeah, we had the IT management tools before. We had the monitoring tools. We had the APM, but most of those tools were not ready for our applications and our infrastructure. For example, if they don't have a transaction topology, then you will not understand the way your application works. You will be not able to track the changes. You will be not able to diagnose the root cause of your failure. Then, if your platform requires you to install the agent each time you are, starting a new application, then of course it will not work, fluently with the applications which are being changed daily. Yeah, those kind of problems. So the IT monitoring tools have to be prepared for the new way we are developing our applications and new reality in IT infrastructure. That's why IBM has decided to buy two companies. One of them was Instana, the second was Turbonomic. Even IBM had APM products before. IBM has been known for developing the T-volume monitoring family for many, many years. It was quite a major technology. We have deployed the ATM technology in many, many different companies around the world. But still, we have decided to get rid of those and to switch to a new products because those products are ready for a new applications that we have today. So there will be two areas that I would like to cover today. The first one is APM, Application Performance Management, represented by IBM Instana, which responds to a question how your application and how your infrastructure actually performs. Are there any problems? What kind of problems? What are the response times? What is the memory for your server? Those kind of problems. The IRM, which stands for Application Resource Management, is not that easy to understand because the concept says that you have your resources like CPUs, like memory, or like disks, like network, and you have to assign those to your application components wisely to optimize the resources that you are giving for your application in order for them to run. So the ARM is responsible for optimizing the assets and assuring application performance. I will tell you about it very, very soon deeper. But let's start with IBM Instana, with our APM platform. The modern IPM platform, the platform which is really ready for today's application, for all the containers, for all the Kubernetes, for all the cloud, and all the things that you may expect from the modern infrastructure. In Instana, everything starts with an agent. The typical way the APM applications are working is that have two components. The first one is the backend, the analysis machine that is getting those metrics from your servers and is analyzing them, telling you, okay, you have a problem with your application. Okay, you have a problem with your server. And then there is an agent part, which is responsible for getting the data from your server from your application. So you are installing your backend, or possibly you're utilizing the backend in the cloud. And then you are installing the agents on each and every server you have. And it is quite tricky because usually we had an agent for a specific kind of technology. Like for the other products, we had a server agent responsible, for example, for getting data from database, or getting data from Java application, or getting data from Node.js application. But when we are talking about today's world, it is not a good idea to have a agent dedicated for specific technology, because the technologies are being changed constantly. If you are utilizing the Kubernetes platform, the new application can be started in just a second. If the Kubernetes platform will decide that he need to upscale your application, that it will start a new, instance of that application. So today, we're rather saying that agent needs to be single, but the agent should do the auto discovery of your services, and the agent should orchestrate them with the so-called sensor. And that's how the Instana works. So we are installing only a single agent per single server or single operating system, to be precise. And then the agent will look what is exactly running on your server. If the server will find, for example, the Java application, it will start Java sensor, starting automatically to monitor your Java application. If it will encounter Node.js application, then it will start a Node.js application. And it is constant process. The agent is starting and stopping those sensors completely automatic. So you don't need to, bother about that. It's just, it's automatic. It's just happening. So our sensors are responsible for getting the data out of the application that you have. They are giving you information about the utilization, about the resources, about, all the critical aspects of your middleware products, operating systems, and applications. Also, the sensor and the agent are responsible for getting the topology. Topology is an information how your applications are connected together. Surely enough, we had those kind of products even before we have started the concept of the cloud native applications. But usually those so-called application scanners, topology scanners, were working, not constantly. We did weekly scans, monthly scans of your IT infrastructure, creating that simplified topology for your systems. It is not sufficient these days. Instana is doing that differently. Instana is tracking each and every call which is happening in your IT infrastructure and is giving you the topology at that very specific moment. So it is always correct. It is always up to date because it is being scanned, constantly. At the same time, the transactions are flowing through your infrastructure. So you can easily find how those modules are connected together. How looks the topology of your application at that specific moment of time? Or for example, what endpoints are has most utilization? Or for example, what applications are running on specific servers? So there are many questions that you can answer when looking on our application topology, which is discovered automatically. No manual intervention for having the application topology for most of the technologies. But this is not the end. Today, we are rather saying that the crucial requirement for the monitoring product is not to see the components, like for example, to see the database, to see the server, to see the operating system. But most critical part is to see end user applications, not the services, not the components of application, but the application as a whole, as a set of interconnected resources, interconnected services that are being used in order to deliver specific service for end users. So application can be, for example, billing system or transaction system for banking, or transaction server for or reservation system for airlines. Those kind of end user application that inside, in our server room, they are being formed by a set of different services. Instana allows you not only to see the metrics for your components, but also to see the metrics for your application. You can see if your application works, what is the error rate, what module is slowing the application. Every kind of question about the application response can be answered by that concept. So you are free to create application as you have defined them in your IT. Then, of course, we have an event. What is an event? Of course, it is a notification that something has happened. For example, if the response time of my application is larger than 200 milliseconds, then I have a problem. So I will set the watcher, which will look for the specific response time. Or for example, if the memory utilization of my server exceeds 90%, that I have a problem. So you will set the watcher. Of course, there can be different kind of event or problem detection technologies out there. Some of them are based on the thresholds, as I told you before, or there are some more clever, I would say. So they are based on AI mechanisms that will keep track about the application or service response times. So that's the event. So Instana will try to verify those rules that you gave and will inform you if the rules has been broken in a form of event. Those events can be grouped together to form an incident. Incident is a set of events connected together using our topology. So if Instana will see that there is a problem with the service, and then you have a set of events on the transaction tree, which may be related to that specific event that, says that your service does not work properly, then Instana will give you that information in a form of incident, showing you what is the problem, at what can be a explanation for that problem in order for you to find to resolve that problem. Then the analytics. These days we are no longer saying that we are selling the APM platforms. Rather, we are saying we are selling the observability platforms, because they are giving you total flexibility in using the data that has been collected. So for example, if Miroslav had a problem yesterday with the transaction system, he could not log in. There was a kind of problem. He doesn't remember what was the problem, but he's calling to you saying, okay, can you, help me? I could not use your system. Then you are free to use the analytics modules of Instana in order to find the transaction and to diagnose the root cause behind that problem. And by the way, Instana is also ready for modern way we are delivering the application. So if you are using CI/CD methodology, which is responsible for constant, let's say, testing and preparing and installing the applications, then Instana will inform you that you have a new release of your application. So it is not exactly the same application that you have, let's say, 10 minutes before. So we are also ready for that. So in a nutshell, Instana is giving you all the data you need. So you have your metrics saying how your components are working. Then you have your topology, how they are connected together. You can see the transactions. So what are the data flowing, how the data flows through your application. Also, you will see the key errors on those transactions. Then the most important part is that Instana has a lightweight infrastructure, or it is lightweight for your applications. Developers are creating those sensors in order not to overload the application servers. So we are collecting 100% of transactions. There is no other option. We are collecting all of them. No data is being lost. And even we are doing so, we are doing it in a way that it does not influence the application much. Of course, there is some penalty for getting those transactions out of the application, but they are rather on a low level. Then intuitive. Yeah, these days we no longer can utilize the application that has bad user look and feel. In a moment, I will show you the Instana demo. You will judge by yourself. But from my standpoint, the Instana is very, very intuitive product with a good-looking screen. So it is nice to use it. When I have switched from the older former IBM products to Instana, I was, extremely happy. Then I got a product which not only works but also looks great. Then Instana is a modern platform, which means that inside it is a microservice application, but also on the outside it can work with a new application. Of course, it can also work with the older ones. If you have a monolithic application, fine, we can monitor it. But if you have containers, if you have Kubernetes, if you are using cloud, it's even better for Instana. Instana is able to do all of those. So, of course, there are some other products on the market which are responsible for more of the same. So we are fighting with those, products like Dynatrace, AppDynamic, New Relic, but usually, always Instana is in a group of the best products on the market. Instana is quite new product. Instana has been created in 2015. IBM has bought Instana in 2020, but even it is not an old product, it has a lot of customer references. Rather not in CE countries. So Instana has decided not to sell their product in so-called Eastern countries like Poland, Lithuania, and other countries from that part of the world. But when IBM has bought Instana, it has changed. So we'll have very, very soon the customer references in Poland, and not only in Poland, because Instana has been sold in many different accounts around the sea. So you will see a lot of those very, very soon. But please note that even Instana is a relatively new product. We have large customers, like, for example, Adidas, Walmart, and many, many others. Yeah, I would assume that probably you are sleeping this time because, the presentations are boring. Sure, it is true. So let's try to switch to the Instana demo in order to see how exactly our beloved Instana works. So let me quickly switch to our demo instance. How can I do that? Probably I need to share my screen that pick the Chrome tab. And right now you should see Instana. Can someone confirm that you can see my screen? Probably you are sleeping. Miroslav, can you tell me if I'm sharing? Marko, can you see my screen? Okay.
Yes.
Okay, I see responses on the chat. Okay, thank you. So thank you very much. So probably you are not sleeping. I'm trying to do my best, telling you, in the way you can follow me, but it is usually hard to follow when someone is showing, some slides, which always works, and there are no problems out there. So it is easy. Let's see if Instana actually works. I have connected to my demo instance. That's the demo server. In fact, I've got two of them. I will connect to another one. I will use those two because one of those is the system where I'm the administrator. The second one is a system where the data resides. So the demo system, the one is the administrator, the second is demo. So I need to change the way I'm showing you my screen, because I will need to switch between those. So let me change that. It will take a second or two. Yes, screen number 2. Yes. So probably you can see my screen. And there are two Instanas. The Instana I'm showing you right now is an Instana where I've got the data. The Instana that I've got here is an Instana where I'm administrator, so I will switch between those. Everything in Instana starts with the agent. So in order to monitor your application, you have to install the agent. Single agent per server, not multiple, just single one. So it is not so hard to install that. How we are doing that? It's easy. Just go to the agents, go to the installing Instana agent, and pick the platform you would like to install the agent to. As you can see, there are only the platforms like operating systems, cloud platforms, or container platforms. There are no databases, there are no Java, there are no PHP or another kind of technologies, because as I told you before, we are installing the agent, and the agent is starting those sensors on its own. So we have to just pick the kind of server we would like to monitor, for example, Linux, then pick the way we are installing the agent and copy and paste the command or install the component that is provided by Instana. And that's it. So when we did that, the agent will install on the server, get started, and then connect to our backend, starting to monitor of our applications and feeding the platform with the data. Of course, it's easy. You can also monitor the state of the agents. Like, for example, if you'd like to see how the server performs, okay, it's disconnected. That one is disconnected right now. But for sure, there should be some more. Yeah, you can see if there are any issues, what is the load which is introduced by the agent. You can even look at the log of the agent or change the way the agent works using the tools which are provided here. So it's quite easy to, to have your infrastructure under control by our agents. Then you will have your data. When agent will be started, it will start also the sensors and will start to monitor the components that you have on your applications. Usually it means that there will be many different sensors opened. For example, for that specific server, we got 54 sensors. So 54, let's say, modules or technologies are being monitored on that server. Each and every sensor will give you a data about a specific kind of your infrastructure, like, for example, about your application, about your web server, about whatever you have out there. And you can look on that information using Instana Desktop. The desktop is being divided into few categories, like websites, applications, platform, infrastructure, analytics, and events. But those are only the entry points. Inside, the data is flat. I would say that you can go, for example, from the infrastructure to the application, from the application to the platform, and so on. So it's quite easy. Let's start with our infrastructure. Let's open the infrastructure tab. Infrastructure shows you all the components that you have connected. So there can be some cloud components, like for example, AWS Lambda. There can be some servers, so cloud servers, so components. So each and every item that has been discovered or connected via agent will be shown here. It is quite easy to get from this screen to the actual modules or for your application. You can utilize the filtering tab. I will not do that because it's boring. Instead, I will go into the tags and use the tags that has been automatically discovered. So, for example, let me show you the server that our dispatch, or maybe not dispatch, maybe discount module works. So what I have to do, I have to just pick application equals discount, the automatically discovered tag, and then it will be filtered out. If I will click on that, I will be informed about my application that I have selected using the tags. It's very powerful because you have not only an access to your application, but also to the components related to the technology. For example, this is a Spring Boot application. Yes, it runs in the JVM, so you can switch to the JVM. Then it is inside the Java process. You can switch to the Java process. Then it is running in a Docker container. You can switch to the Docker container. Then it is inside Kubernetes pod. You can switch to Kubernetes pod. It is running on Kubernetes node. Of course, if it runs in the pod, it has to run on specific node. So there is also a node here. And there is a logical server that the application is running on as well. So you can just pick and open each of those. Let me start with the server, with the operating system data. I will open the dashboard for that. And yeah, as you can see, I have all my details about the operating system or a server that my module is running on. So you can see the characteristic on that, and you can see all the components that has been discovered. So for example, there is 14 containers running on that server. There are 3 applications, the Node.js applications. There is one Python application. There is one Spring Boot application. Of course, if I will expand that, I can go to each and every component directly to see its data. On the right part of the screen, I got the actual data. Right now, I'm seeing the data from last 7 days. I can easily change the time frame that I'm looking at, or even I can go to the releases to see the releases of my application. So it's up to you what period of time you are picking. And then you can see all the data here. Let's imagine for a moment that I have opened, or maybe not I have been informed that we've got a problem with a server name, GKE, public demo, cluster default pool, something like that. Okay, I have opened the screen for that server, and I know that I have a problem with that server. It is not working as it should work. So, of course, I can diagnose the problems that can be related to my server, but the most important part is what application is running on that server. Can I answer that? Sure, I can. Just go to the stack, and then I can see that that specific server provides 9 endpoints, has 5 services, I mean the application components. It is part of 3 applications. It is also a part of Kubernetes cluster named public demo cluster. There are 7 namespaces running on that, 2 daemon sets, and 12 deployments, Kubernetes deployments, and there is also an infrastructure view which says the infrastructure aspects of the topology. So I can easily diagnose what kind of application is running on the specific server that I'm showing. Of course, I can also easily switch to that specific part that I'm interested in. So for example, let's imagine that, okay, maybe I need to diagnose the discount module. So let's go. Let's open it. As you can see, the screen has changed from the operating system metrics to the metrics for a module of my application, for a discount service. So I got number of calls, number of error calls. By the way, slightly above 5% of calls are with error. So for sure, there is a problem with the application. It should not perform like that. The mean latency, 173 milliseconds. It's okay. Even better than for 90 of them, it's only 7 milliseconds. We'll get back to that. But sometimes, as you can see, the response time goes to a huge number, like a few seconds. Why? Well, let me show you in a second. Then the processing times, as you can see, most problems are related to database, as you can see. If you will switch off the database, then there are also almost no problems. I will expand the time frame. As you can see, usually the database is the main reason for application slowness here. There are some changes because we have deployments. We had also some incidents for that application, and there are the endpoints for my application with their latency, calls, errors, calls. So if you are interested in diagnose those, it's very, very easy. Of course, I can see also how my modules are connected together. So as you can see, my discount service calls JDBC and calls discount DB, but inside it is being called by loyalty program container and catalog demo. I can even expand them to see other application modules. I can also add transactions that are occurring and color, for example, with the number of errors. So as you can see, the JDBC module is bad one. It has 100% of errors. I can also look on the endpoint to see the error messages, see the infrastructure. But the most interesting part here is that I can look on the actual calls. If I will open the Analyze Call button, which is right here, Instana will switch to the transaction view or a call view. What we've got here, that's our histogram of response time. So as you can see, 95% of the calls are faster than 10 milliseconds. So are we good? Oh, not really. As you can see, 1% of those takes more than 5 seconds. Can we diagnose why? For sure. Just select those slow transactions, and then you can see that those transactions are related to get, find, SKU endpoint. And by the way, that's are the transactions. All the transactions from last 24 hours that were longer than 6 seconds. Can we look on the specific transaction? Sure. Just click and you see all the calls, all the database commands. And by the way, if you are interested, you can look on the source code is being decompiled automatically. So you can also look on the stack trace to find what has actually happened in your application. So it's quite easy to find all the reasons for the problems that we have. I will get back to that very, very soon when I will be covering the end user perspective of the transaction. But let's go back to our service, the discount service. Okay, let's imagine once more that, okay, someone has informed us that, yeah, we have a discount service which performs badly. There are some problems with that. So the question is, okay, the discount service is a part of application? Probably yes, but which application? Yeah, that's the good question. Can we find it? Of course. Just go to the stack and you will see that that's discount service is a part of 3 applications: Robot Shop, all services, and Node.js applications. I can open the dashboard for that. As you can see right now, I'm on the Robot Shop with front-end applications and user application. There is a lot of calls in that application. Oh, yeah, there are some bad calls. As you can see, the processing time is mainly influenced by the HTTP layer, not the database layer this time, but for HTTP. There are some top services in terms of latency. The most problematic service is IBM Shop. In terms of calls, the most calls goes to IBM ratings. If we are talking about the error calls, then IBM frontend is the most problematic service in that specific application. Of course, you can draw the map of the interconnection in my application. So that's the real-time view of the transaction topology that we have. So it is very, very easy to diagnose how the application is formed in our IT. Yeah, there are some fancy things you can do with that as well. You can look on all the services that are forming my application. So as you can see, there are many different technologies. Some of those modules are written in Java, some of those in JavaScript, in Node.js. We are utilizing also Go, RabbitMQ, Python, MySQL, many different technologies, and that's are the metrics. Of course, you can easily go to each and every of those to diagnose why it performs badly. When we have transaction, there may be some error messages around them, so you can look on those, and also you can look at the calls of your whole application. So this time I can show the data flow, the transaction that goes through my full application, not one service like a second before, but for my whole application. But it is not the end. This is only the backend view of my application. So I can easily diagnose what is happening in my on my servers, but sometimes the problems are happening in different area of IT application. It is on the front-end application. Can we look on the front application? Sure, we can. We have websites and mobile applications. There are two tabs, website and mobile application, of course. I don't have any mobile application right here, so I will not show you that, but I can easily show you the websites. If I'll open the Robot Shop website, then I will be informed about my front-end performance. Oh, so as you can see, the average load time for my application is slightly less than 3 seconds. It's okay. 95th percentile of response is 6.61, not so great, but it's okay. There are some JavaScript errors. There are my clients coming from many different countries. There are top pages called. So there is a lot of, let's say, statistical level information which allows for your developers to diagnose the front-end application performance. Of course, for each and every component, there is also information about their current state. Like, for example, right now we have an issue open for, okay, it's already been closed, but we can see here an issues open for my application that I'm looking at. So it is an entry point to the events, which I will show very soon. But there is one more tab, the button. There is Analyze Page Load. When I open that, I will have an access to each and every transaction which comes from the end user. So let's assume that's the Miroslav transaction that has happened yesterday, and I would like the reason why he was not so satisfied. So let me open that. By the way, it's not Miroslav, it is Laura, okay? As you can see, that's the performance of the application resources from the application, let's say front-end application or browser point of view. So there are all the metrics, all the data that has been requested with their state. If I will see no reason for the problem right here, I can easily switch to the backend view. There is a button, View Backend Trace, which will show me the second part of the transaction. So this is the browser part, but this is the backend trace, the backend part of the transaction. So if I will switch, then I will see exactly the same transaction but from our backend point of view. So that's the timeline for the calls, that the services which were responsible for delivering the transaction, and that's the structure of the calls with all the, database calls or the response times and all the errors if there are any. Right now we don't have, but for sure if we'll open another, then we can have some problems. Like, for example, that specific post failed because of the problem with the loyalty discount service, which was, as you can see, 132 seconds long. That's our websites, and we also have analytics, which allows me to see the data. For example, if I'm interested in profiling the application code, then I can go to Profile and to find my application and see exactly where the application is losing the CPU power, or utilizing most of the memory. So it is very nice information for the developers. But that's not the end. I can look on the application calls, traces, websites, mobile applications. So for example, if I would like to see all the database problems, so let me switch to the database calls, not for last 24 hours, but for last few days. Let me expand that. And then, of course, I would like to see the slowest one. So let's get those. But I don't want to see operations, but I would like to see the database statements, the commands that we have sent to our application. Okay, that's the calls that were most problematic in last 7 days. As you can see, Instana works very fast. There is something like, let's say, 5 or maybe 6 million of calls we are filtering right now, and it works fluently with no problems at all. I can expand and look on the specific call to see what has exactly happened for that. So it's very easy to navigate, and also I've got my event subsystem. I can see the issues, so the problems that has been detected, like for example, the database has been stopped, or the number of, the system load for my server is too high. I can see also the incidents. Incidents are, different events grouped together. So for example, there was a problem with a discount because there is a sudden increase in number of error calls. And there are possible reasons for that. Probably the reason is because the discount DB service has failed. So from my standpoint, it is very, very easy to work with Instana. You can see all the data from your infrastructure up to your transactions, your applications. I hope that you will agree with me that navigation in that product is not so bad. It's quite easy. So as I told you before, I'm more than happy to use that platform for as a monitoring product. Let me go back to my presentation because I got some additional slides to show you. So let's go back. Let's click stop sharing, and then let's start share my screen, which should be here. Okay, so that was my quick Instana demo. We got a few other slides to show you. As I told you before, if we are talking about Instana, we have two options for the backend. I mean, the part which is responsible for analyzing the data. You can opt to use a local instance, I mean to install Instana in your own server room, or you can use a cloud instance of Instana, which does not require you to install anything in your infrastructure except for the agent, of course. Each time, if you would like to monitor your server or servers, you have to install a single agent on them. As I told you before, we are utilizing the single agent concept, where we are installing only one component, and the agent is responsible for starting the so-called sensors. All of those are listed on the Instana documentation. So if you are interested, if Instana supports your specific components, then it is quite easy to go to look at the Instana documentation. Each and every component should have their own sensors. It is not a full list of them. There are many, many more out there. So it's just for you to see that there is a lot of different technologies we are covering. Also, we are supporting the transaction tracking system. So if you have already invested in, for example, Open Tracing, Open Telemetry, Zipkin, or another transaction tracking technology, then Instana can directly consume that information and to utilize for that. In terms of platforms, we are supporting, of course, we are supporting Linux, running on different processors. We are also monitoring Solaris and IAX. We can also support Windows and macOS. So most of the technologies that are being used these days are already supported by Instana. And also we are open for integration. So for example, if you'd like to get the data out from Instana, okay, no problem. There is an API for that. If you'd like to see the notification or the events coming from your systems in your workgroup products, okay, no problem. We have an integration for that. So that's our Instana in a nutshell. So we will switch to the Turbonomic, but before that, let me welcome Marko, who will tell us something about Instana in reality. Marko has a huge experience with working in Instana and will be more than happy to share some insights with us. Marko, are you with us?
Yes, I'm here, Maciej. Thank you.
Thank you.
Do you hear me?
Yes, perfect.
Okay, great. Thank you. Let me tell just a short about myself. I'm working in DualSoft, a company coming from Serbia, for the last 10 years. And before that, I have experience working in some other companies as well. So around 20 years of experience, like a support and DBA and sysadmin and things like that. So we started to work with Instana, I think around, it will be 2 years ago. So we have worked previously with Nagios, Zabbix, we also have Grafana, Prometheus, and other monitoring systems. But we decided to find some company which will give us some more insight about how our applications are running. So we discovered the New Relic first, and then we were not so their product could not cover all the aspects that we needed. So we bumped on the website of Instana, and that's how we discovered the product. And we started our demo first, and then we are decided to have Instana in our production environment. So we have bought the licenses and everything. So we are running Instana agents approximately around 200 our servers at the moment. So in production we have around 180, and the 20 I think is in our development stack. So we are covering mainly Java applications. So we are using a lot of different infrastructure platforms like Cassandra, Redis, Rabbit, I don't know, for messaging there is Kafka as well, so Elasticsearch. So our applications are connected to all those services. At the end, we have Oracle database. So we use Instana primarily as alerting system. So we have actually set all the connections, alerts actually, that are getting to us through Slack channel and through our mail channel. So anytime that we have problem with some server, it doesn't matter if it is CPU or memory load or disk load, so we get an info about it on those two channels. Like I said, we are mainly Java. We have applications mainly in Java. What we are working in a betting system. So our application is betting application. So we have a lot of customers. So we use Instana to cover all the problems that that system is running through, and it's 24/7. So which means that we have a full support engineers that are working in shifts to support all the customers that we have. So if you like, I can show you how it looks like on production. So I will try to share my screen. Let me share my screen. Just share screen. Okay, so I'm running on maybe a slow computer, so something will be maybe slow. Okay, so like I said, we are running our application on Rancher Kubernetes platform, and I will show you our main infrastructure screen from Instana. So those all small things represent our clients. So we have divided them like this. So one of them, for example, this one is something that we host around here, our space. So this is a perspective from where we are able to see the hosts that are included in this rancher system. And I can show you the agents, for example, agents view. Mate already covered that, but how it looks like from our perspective. So we have different types of containers and public Docker and things like that. So I have prepared two of the problems that we have. Two of them were today. So we have noticed, this is our rancher Kubernetes. So we have noticed that we have a lot of restarts during the weekend. One of our pods restarted. The main reason for that we discovered on Instana. So this is that pod in Instana view. So we used this perspective to trace that problem. So these are our deployments. So one of the problematic one was GNS RabbitMQ sync, and we discovered that that pod actually was running out the memory. So when we take a look that deployment, in 2 days ago, we have noticed that the memory that we gave to the that specific pod was too small. There was not enough memory, so that caused that that pod restarted every time. So we got that information through our Slack channel. From Instana, and all the notifications that that we are receiving are mainly coming from the Slack channel. So when we got that notification, we checked the problem here on Instana view. So we figure out that there was not enough memory. So we raised the memory limit, and that's how we solve, for example, that problem. We also, I can show you how it looks like. This is infrastructure or now development service, and I can show you one picture just to see. Yes, this is from analytics. Also, here we can see how we got Instana problem through Slack channel. So we have found that this procedure was problematic, and there was a message in our log and Instana log as well that there is no data read from the socket for this call. And we have tried to find out what happened. We have seen that aggregated time for this procedure was latency actually was too high. So we got that in Instana, and then we tried to find the solution for that. So we find that this message, no more data to read from socket, was also on registered on Oracle web support website. So there is a bug with that procedure when the Oracle do dequeuing from one queue to another. In case you have more than 1,700 records in it, so it's going to fail. So we, open the bug backtracker to Oracle website, so we are waiting for an answer for that. And I also have one more screen, just try to find it where it is, how it looks like. Yes, this is our platform services. This is how it looks like in our production environment. It's a total mess, but there are, all the connections through, you can see easily, not from the main screen, but if you check, you can go to the flow and see only for that service how the traces are flowing, go to the dashboard and things like that. So this is our main perspective. In summary, main platform services, and this is applications screen. So we have different customers as well. For example, this is one of our customers. So when we click to their website, we are able to see infrastructure issues, changes, latencies, stop services, everything we need to know at the moment what's going on. So actually, we are using Instana to leverage our business in a way that we are try to detect the problems that are going through our system, which is not so obvious. So when we need to go in deep analysis, so we have a lot of help from the data that are coming from Instana. So I think that Matej also covered all the screens or Instana functionality. So this is how it looks like in production. So it's a pretty big system from our perspective. It's a little bit confusing, but Instana offers us a lot of different ways to track the calls and to find bottlenecks in our system, so we are able to provide better code and some problem solving using that analysis. Yeah, so would you like to maybe show you just something more, or is it enough?
I think it was great because it's always good to see the real systems and real data. All I can show are the
Yes,
demo systems. They are not live, so it's completely different. I really appreciate the application topology, which is the greatest I have ever seen on Instana. So it's
so they're getting bigger.
Yeah, it's huge.
We're getting bigger, so it's getting more and more complex. So we have a lot of microsystems that are working. So a lot of different, like I said, a lot of different platform services, infrastructure, databases, Postgres, Oracle. Then we have MariaDB, and we have Cassandra. So you show them that they can use perspective or tags, to find easily and get through for example, if I want to see one of our microservices application, which is involved in ticket processing, so I can easily jump to that and see, do I have some, for example, latencies or some erroneous calls? So I can open dashboard and see where they are running, on which server, and then I can find the specific pod and to see what's going on. So Instana agents always inform us in case we have any disk load or I don't know, CPU pressure or things like that. So we are trying to cover all the different technologies that we are using through this Instana. So we are always we have an eye on every process that we have on our system.
Yeah, great. Marko, thank you for your presentation. As I told you before, it's great to see the living system, the live real data. Thank you for that.
Okay.
So probably I will switch to the second part of my presentation. Hopefully there are still people out there. I cannot verify if you are listening to us, if you are happy with us. Sorry, we can't see together. That's the reality of today's times where we don't see each other. We are rather using the online systems. But let's switch to the second part of my presentation, hoping that you are still with us. So let me share my screen, let me share my presentation, and you should see, yeah. Let me go back. Right. So the step number 2 is the mystery problem of solving your ARM problem. Of course, you may ask me, do I have the ARM problem? Well, let me answer to that. So, probably you will agree with me that IT these days is critical. It's even more critical when we have a COVID times that it was before. So we are, or companies, or governments, or people around the world are giving a lot of money for IT to work. Why is that? Of course, because there are some applications running. So IT does not work for the servers. IT does not work for the components, for whatever we have. IT works for the application. So assuring the application performance is the only reason the IT department works. So if the application fails, then we have a problem. So the ARM problem, the mystery ARM problem, is to assure that the applications that you are running, which are extremely important, which are the core of our IT, performs correctly all the time. Part of that problem is, of course, the detection of the errors, which are, let's say, which are being solved by APM products. But APM will not solve the problem for the performance assurance. Another question: what is the reason for applications to suffer, for application performance to suffer? You may think that there are some software bugs. Yes, sure, there are. On average, not more than 10% of performance-related problems are because of the software bugs. We have a good tools to debug the application. We have a good tools to work with the developers on that. So usually they are not. The second thing, human and configuration errors. Sure enough, yes. If someone will do a mistake, then we can have a performance problems, but still it is not so common these days because we have a procedure for that. For example, if you are utilizing CI/CD, then we have a procedure to deploy the application, to configure the application. So usually it's not really a problem. Then possibly a hardware failure. Yes, sure, but modern data centers are, designed with a redundancy. So we have a multiple hardware platforms. We have methods to migrate the application from one to another. So usually the reason behind the performance problem is the resource congestion. What kind? There are many different kinds of congestions. So for example, Java heap may be exhausted, sure, or the virtual machine is not getting the IOPS from the disk subsystem, or things like that. So they are many different kind of problems that are related to ARM concept, to ARM management. And that's why we are trying to solve ARM application resource management problem. By the way, which sometimes is by mistake is defined as a cost problem. Many different times when I'm going to a customer and talking about that area of problems, I can hear that their problems is that they are paying too much for the application, so they would like to reduce the costs. But in fact, it is not something they want, because solving the problem of costs is very easy. Just switch that off. Nothing more. Switch that off. If the cost is your problem, then switch them all together. Okay, and then customer says, okay, no, I cannot switch them because that's my application. They needs to be running. So you don't have a cost problem. You have a performance assurance or optimization problems where you would like to have your applications running properly, but in the optimal way, not paying for things that you don't have to pay for. Yes, that's the real problem of ARM. So ARM is a problem how to assign the resources for your applications in a most efficient way. How we are doing that? So let's look on our applications. If we are talking about the applications, we are seeing them as a so-called business application or application in terms of Instana and Turbonomic, so the end user application. Behind that, there are some business transactions, some services which are responsible for those transactions, and also the application components which does the work. Yeah, they're getting the data and processing the data. But that's not the end. Of course, we are usually defining the applications as a layer of those 3 or 4 components, but not forget about all the infrastructure that is behind that. Why it is important? It's very important because if, for example, you have many users in your business application, then it will create a lot of business transactions, which will go through the services, which will go through the application components, which will run on the container or a pod. The pod will run on the virtual machine. The virtual machine is created in virtual data center on a specific host. The host has connected the storage. The storage is, composed by specific volumes or disk arrays. And also there is a network layer, and each and every layer has its own resource consumption and reservation. Each and every can be misaligned. That's the problem. The problem is that we are not really able to properly size all of those. Why is that? It's because we don't have any information. When we are trying to start a new application, usually we don't know how the application works in reality. How many CPUs it needs, how much memory it needs. Do you know that? Usually not. And also, if you are starting those applications on different layers of technology, like for example, in a pod or in a virtual machine, that there are still some components behind that. And you need to size all of those properly. So even if you will assign proper amount of cores for virtual machine, if there are no free CPUs available on the host, then you will have a problem because, yes, there is a client-server relation. The host is giving the CPUs to the virtual machines, but if the resource of CPU is limited there, it will not be able to do so. So you have 2 options or maybe 3 options to size your resource reservation. You can go for the bluish or grayish part of my screen, which stands that you are assigning too much for your applications. Usually it means that your application will perform properly, but for a very high cost. Or you can go for the red one, where, okay, your hardware is utilized, so probably the price of your IT is lower, but you will have a performance problem with your applications. Because if the IT is overloaded, then application does not perform as expected. And remember that those congestions, those reservation problem can be seen on each and every layer of the delivery chain. So we are usually sizing the virtual machines. We are sometimes sizing the pods. But how about the IOPS for disk arrays? Yeah, is it easy? No, it is not. Usually it is something that we cannot see. Or how about the proper version or proper cloud instance? Is it easy to do so? Not usually. I will show you that in a second. So sizing is not so easy, which means that on average, we will see the problems. Someone will be not able to finish the transactions. The response time will be bad. The data will be dropped because there will be, congestion on a specific layer of our IT. How we are dealing with that? The first part is that each and every team in IT has its own tools. Database guys got its own tools. The network has own tools. But they usually don't see the whole perspective, whole system. Usually the network team does not understand the applications. The developers don't care about the servers. That's the reality. So if the problem is happening, if something has happened, if your customer could not connect to your system and you are working on the problem, what is the main answer that teams are giving? From my perspective, it's not me. Okay, we've got a problem. We are going to the, let's say, application stuff. It is your problem. No, it's not me, it's the database. We are going to the database guys. It's your problem. It's not me, it is a network, and so on, so on, so on. So the main, usually, I'm not saying it is the case in your company, maybe not, but for most of the companies, the main problems of IT personnel is to say that the reason is not on, the fault is not on their side, but the problem is that the person who wants to use our system still cannot do that because it is not easy to size the systems. It is not easy to assign proper resources, to analyze all the requirements, to analyze the requirements that is changing in the function of time. So if we've got more customers, more people are utilizing our system, we need to deliver, to have a more performance for that. That's obvious. So it is not easy to properly size the infrastructure, especially that there is a lot of components. I told you before, we have containers, tens of thousands of those. We have applications that are being changed constantly. We have different tools working together. We have different tools, management tools. We are not giving you the same information. So it is not easy to diagnose that. And in addition, if you are utilizing not only the on-premise, I mean your own server rooms, then probably you are using a cloud as well. And it is even harder when you are using the cloud resources. Why is that? Let me show you. I have prepared a screen which shows the Amazon AC2 instance types. I had an idea that I will create one single slide which shows all the possibilities that you have out there. And I have started creating that slide and failed because I could not put all of those. So I have decided that I will show only the general type of those machines, but still I have failed because I could not show all of those because there are too many of them. And please remember that each and every kind of this has its own price, but also its own number of CPUs, own number of memory, own number of storage connected, own number of network performance assigned to that. So it is extremely hard to properly size those. It is extremely hard to pick at the best combination between the compute, storage, and network attributes of each other. That's why we have Turbonomic. If you have the on-premise server room, I mean, you are not utilizing the cloud, or possibly you are utilizing the cloud, or possibly you have mixed infrastructure. So you have your own servers, but also you are utilizing the cloud resources. Turbonomic is for you. It can detect how your applications are connected together, how they work. So in order to do so, it is connecting directly to management platforms of specific technology. So for example, if you are utilizing VMware, then it will connect to vSphere. If you are utilizing the Microsoft, it will connect to Hyper-V or System Center, Virtual Machine Manager, and so on, so on. So it will connect to the specific technology, the specific system that you are utilizing, and get the data about the relationship model of your application. So it will discover the application that you are using. For that, it will connect to all the application performance management products, like, for example, Instana, but also to Dynatrace, Datadog, and so on, so on, so on. Then you will see all the business application, transactions, and services. Then it will create an abstraction which will form a common model of how your applications are connected or created together. Also, it will see all the virtual machines and containers, all the technology that is inside. And also, it will discover all the on-premise or cloud infrastructure that those applications or those components are running on. Why it is doing that? Of course, it is for a reason. And the reason is that Turbonomic is creating the topology in order to analyze what is exactly happening in your infrastructure, because it is not getting only the topology, but the data, the metrics as well. So, for example, if you are utilizing vSphere, it will give you all the details. It will pull all the details about the virtual machines. What are the resource reservation for them? What are the servers that those virtual machine has been created on? And what are the resources available on that specific server? Then possibly it will discover that the specific server is connected to EMC storage subsystem. So it will find all the details about the storage system as well. Then possibly it will find out that there is a database running on that. So it will get those information from the database. Then possibly it will find that you are utilizing the cloud platform. So it will connect to the cloud platform. Of course, you need to provide the credentials, all the details, how to connect to those. But then it will connect to those platforms and pull the data from that, forming not only the transaction tree, as you can see here, but the metrics as well. What is the performance of your application and how the performance is related to resources which are available for your application? And then it will do the math. So, for example, if there is an application which has a huge load created by its users, but the application has not enough resources, and those resources are still available on the physical server that the application runs on, it will suggest you to increase, for example, number of CPUs for that specific application. But on the other way, if your application requires more memory, there is a huge load for that application, but there are no resources on the server because all of those resources are already consumed by your application, then possibly it will find another application which has too much resources and will tell you, okay, not only increase the CPUs, not only increase the number of memory for that specific application, but also decrease those for the second application because it is not being used properly, because you are losing your money because the application is not utilizing the resources that you have assigned. And that information you will see as a set of instruction, I would say. So for example, scale down heap, move virtual machine from one server to another, suspend hold because it is not utilized at all, or scale up vCPU for a specific machine, or scale down vCPU, or scale up memory, or change the storage subsystem, or possibly change the cloud instance that you are using because you are not utilizing it. That's very, very important part. So the first aim, the first task for Turbonomic is to assure application performance, to give your application all the resources the application needs in order to run properly. That's the main reason for Turbonomic to be. And the second one is to do that in a good way, optimally, I would say. So, for example, to release the local resources for new applications that you will be able to install, or to lower the cost of the cloud instances that you are using. That's are the task for Turbonomic, not only to assure performance, but also to reduce costs of your IT. And that's in one package. So Turbonomic is doing that at the same time. The quite important part is that Turbonomic is created around the market or a stock exchange concept where there are sellers and buyers. So for example, if we have an application, or maybe another way, if you have a virtual machine, then the application sells the CPU and memory to application that are running on the specific virtual machine, but on the same time, it is buying those resources for a physical host. So it is changing the virtual internal price of those resources depending on the number of customers. I mean the utilization of the resources by application or end users, and the amount of them which are still on the transaction tree behind of that application. So for example, if there is a lot of CPU resources on the physical server, that it will be quite easy for virtual machine to scale up because we have a lot of CPUs. So if application expect to have more, will scale up. But on the other side, if the server is overloaded, the virtual price of that resources is so high that the application will not be able to scale up because there is, they could not afford, because the market decision, the market-driven decision requires to expand when profitable and contract to reduce when those applications are unprofitable. I mean, they are not getting enough virtual money from their consumers, then they are paying for the services from underlying infrastructure, which really responds to the problem how to pick the, most utilized application and the less utilized, and how to assign resources for them. So that's the Turbonomic in a nutshell. So it will give you a predictable, the constant performance of your application, of your end user transaction, because each time, each moment, you will have optimum resource reservation for your application. Turbonomic can, the instructions the Turbonomic is giving you can be instantiated manually, so you are reading and you are doing it manually, or can be done automatically, which means that Turbonomic will reconfigure your IT on the fly. If you are using the second way of working with Turbonomic, it means that each and every time you will have an optimal configuration of your services, regardless if you are using an on-prem system or cloud system. Also, it will lower your costs, usually, unless you have, not enough resources for your application. That, of course, it will do nothing. I mean, it will optimize it, but it will not mean that you will have some, cost reduction. But on average, there is a huge cost reduction if you are utilizing Turbonomic. Yeah, and also it will allow you to plan, for example, migration from one type of server to another type, or for example, to migrate from on-premise to cloud, or from cloud to on-premise. All of those depending that all of those projections will be done on the actual numbers taken from actual real application that you are utilizing. And by the way, this is all we have created today. So that's the end of my presentation. I have no more slides. I will not do the Turbonomic demo. If you are interested, just feel free to contact our team and we'll do the presentation for you. We'll do the demo for you.